Chapter 3 is dealing with inequalities. So we're going to do regular inequalities for like one-step equations. We'll get into multi-step equations, and then compound inequalities, which are a little bit more challenging. All right, so let's start with basic inequalities. We did these last year. Come on, you guys have had plenty of time to write your homework down. I need you getting going with notes, everybody. Okay, so we are in Chapter 3, Section 2. We're going to be solving inequalities using addition and subtraction. Okay, I want to do a quick reminder of what inequalities are, a quick reminder of how we graph an inequality solution, and then we're going to go ahead and solve some inequalities. We've done this last year, so this is not new to you. All right, we just don't do it that often. All right, so let's compare equations versus inequalities. All right, an equation's going to look like x plus 5 equals 15. All right, we have an equal sign between the expressions. Jack, sweetie, come on, man. I'm not sure why it's taking you so long to get to this point. You need to write that down as soon as you get in, okay? All right, so an equation has an equal sign between the two expressions. How can I change that into an inequality? Not how do I solve that? How can I change that equation into an inequality? What do you guys think? Well, this goes to the question of what's the difference between an equation and an inequality. Con? And you put A? I can't just get rid of the equal sign. Nope. Nope. Think of your inequality symbols. Isabel? Sure, I can do inequality symbols. So I have x plus 5. I can replace it. Colin, I do agree with you. Get rid of the equal sign. But I replace it with an inequality symbol. This is one such inequality symbol. So what we do is we have an inequality symbol. Not a not equal to. Colin, that would be equal sign with a line through it. That means they're not equal to each other. This is an inequality. Okay? So an inequality symbol between the expressions. All right, so let's talk about our different inequality symbols. Well, we already have that one, so let's talk inequality symbols. Well, I have this one. What is the name of that one? What is the name of that one? Matthew? Yes, exactly. Greater than or equal to. Nice job. So that is a greater than or equal to. When you're reading from left to right, how you figure out the difference between a less than and a greater than. When you're reading from left to right, if the bigger side comes first, it's a greater than. If the smaller side comes first, it's a less than. All right, so what is this called? Without the line underneath it. What is that called? Nick? Yep, that's just a greater than. All right, what is this called? Sam? Excellent. Less than or equal to. All right, what is that called? Jacob? That's just a less than. All right, let's look at what an example of a solution to an equation and a solution to an inequality would look like. So solution to equation might look like x is equal to 10. The solution to inequality is going to look like x is greater than or equal to 10. All right, so those are the difference when it comes to what in an equation statement or an inequality statement or an equation. And now these are the difference between visually what a solution looks like. Now for inequalities, we typically graph our solutions. So let's remember how to graph solutions to inequalities. Who needs to see what's up there? Okay. Who needs to see what's up there? All right, so let's graph inequality solutions. All right, so we have two elements that we are graphing. The first one is the dot. All right, the two possibilities are this, looks just like an O. This is called an open dot. All right, that's when we're using a less than or a greater than symbol. All right, so what that means, and I'm going to remind you what start number means in a second. So what that means is the start number is not part of solution set. The other possibility is what's called a closed dot. That's when we have a less than or equal to or a greater than or equal to. All right, this is when the start number is part of the solution set. Do you guys kind of remember doing this last year? A little bit? Okay. So let's practice graphing these. I'm only going to practice a couple because we're going to get right into solving, and we'll graph some when we're solving too. Okay? Okay. So let's graph this this solution. So let's graph x is greater than or equal to 5. Okay, so our start number is the number in our solution. So when I solve an inequality and I get down to this, x is greater than or equal to 5, that 5 is called our start number. It's where our solution starts from. So I'm going to go ahead and draw my number line on a grid line. All right, I'm going to show my 0. And I'm going to put a couple increments out to at least my number. If you're counting by ones, I don't need to see what you're counting by. I'd like your 0 on there for sure, and then your start number. So here our start number is 5. So 1, 2, 3, 4, 5. So the first thing you're going to do is you're going to graph the dot at the start number. So What type of dot am I graphing? Am I graphing an open dot or a closed dot? Peter? Why closed? Yeah, it's a greater than or equal to. It has that equal to part to it. All right, the second part, oops, I didn't talk about our second thing. So in our elements, our second thing for our element is our shading. We'll talk about our shading right now. So the second thing here is our shading. All right, so when I do my steps here, our next step is shading in here, but let's talk about shading. All right, shading it represents all possible values for the variable. So the shading represents all possible values for the variable. So always look at which side of the inequality symbol is facing our variable. All right, so if the bigger side is facing it, my x's are bigger. If the smaller side is facing my variable, the x's are smaller. So which way am I going to shade in this one? What are all my x's in relation to my 5? Are they bigger than my 5 or smaller than my 5? Based on this. Come on, everyone's looking. Are all my variables bigger than my 5 or smaller than my 5? Victoria? They're bigger. So I'm going to shade bigger because the x is greater than the 5. So these are my possible, that shading is my possible x values. That's what that shading represents. Is this slowly coming back to you guys? Nick. Yep. No, it's not going to be hard to see the shading because you're going to shade it, so it's not going to be hard to see the shading. For sure, you can use a different color. I have to see what type of dot it is. And I have to see your shading. So if you want to use whatever color you want to do the shading, have at it. And you can do the same thing on a test or a quiz as well. So if you want to get highlighter right and highlight that side of it as the shading, if you want to just get your favorite color pen, that's fine with me. Okay. So I want you guys to graph this one. Let's graph -3 is greater than t. All of you graph that, please. Okay, so what kind of dot am I going to graph and where am I putting my dot to start with? Blythe? Where? What is it? So there's my -3, it's an open dot. Okay, and what are all my t's in relation to that? Smaller, because the smaller side of the inequality is facing the t. I was trying to throw you guys off here. Jack, please don't lean back in your chair. How many of you guys got that? Okay, so don't look at this saying -3 is greater than t, so that means I have to shade everything greater than the -3. You're looking at seeing which side of the inequality is facing the variable. Whatever side is facing the variable, if it's the smaller side, then your variable's smaller than that number. If it's the bigger side, then your variable's bigger than that number. Yes. That only works if your variable comes first. So I think that's what you're saying. If you look at the variable coming first, the variable has to come first. If the variable comes first, then your inequality symbol does point in the way of the shading. But if your inequality symbol does not come first, that does not work. So I don't want to rely on the inequality symbol being your arrow in the direction. That only works when your variable comes first. But you're right. That is the case if the variable does come first. Okay, so now let's look at solving inequalities. Questions on graphing them? All right, so let's take a look at solving inequalities. Victoria, I always wait for people to make that observation because I think it's a great observation to make. But you have to make sure that we're paying attention to it. You know what I mean? Okay. So let's solve inequalities. So first of all, when we have addition or subtraction, it is exactly the same process as solving equations. It's exactly the same process as solving equations. There's no difference at all. Once we get multiplication and division involved, we do have a bit of a change, but we'll talk about that another day. All right, so I want us to solve and graph this inequality. So I have x minus 3 is less than 5. So all of you right now to solve and graph that. Someone tell me what to do to solve that. Jacob, go ahead.
So I did adding the opposite.
Love that. Excellent.
So we would add a positive 3 to both sides. And
Okay.
you get x is less than 8.
Excellent. Now what?
And then, so when you draw your graph,
Yep.
your starting number is your 8.
So 1, 2, 3, 4, 5, 6, 7, 8. You guys, please put your 0 on there if you can. If they're bigger, like if that was 18, I might count by 2s. Right? So count by 2s if that's the case. All right, tell me what else to do.
It's an open dot on your 8, and then it would be going to the left.
Excellent. Nice. You guys, you don't have to shade all the way down to the end of your number line. Shade far enough that I can see your shading. How many of you guys got that one right? Fantastic. All right, let's talk about checking our solution. This is different than an equation. Check solution to inequality. If they tell you to check it, check it. If they don't, you don't have to, okay? Checking, what that really means is we are just checking the direction of our shading. You can't really check, did I do this math right? Did I do 3, I add 3 to both sides, did I do that math right? We really can't check that very much. If this was an equation, if this said x is equal to 8, because this is x minus 3 is equal to 5, we would just take that 8 and substitute in for our x. But we can't do that with an inequality. So what we have to do is we need to choose a number, choose a value from the shaded part. So choose any number from the shaded part. What number would you guys like to choose? It honestly does not matter. Make this math easy on yourself. Colin, what would you like to choose? All right, let's choose 4. So we're going to say x is equal to 4 here. Then what you're going to do is you're going to substitute that value in for the variable in the given to see if it makes it true. If so, you shaded properly. If so, shading correct. So that's really all you're looking to see is, did I shade this properly? All right, so I'm going to go down here. So I'm going to put 4 minus 3 is less than 5, and I'm looking to see, I'm going to put a little question mark over that, because I'm looking to see, is it less than 5? So I'm going to put a little question mark over the top of that. Well, 4 minus 3 is 1. Colin, is 1 less than 5? Yeah, so this is true. So we shaded right, or correctly. You guys cool with that? All right, 0 is a super easy one to use if it's in there, right? Use a number that's going to make your math really, really easy on the check. You guys good with that? Okay. I'm going to give you guys another one to solve, and I want you to check it as well. And then we're going to look at a story problem. You guys good? Who needs to see what's up there? So, the directions I'm going to be writing here are solve, graph, and check. Who needs to see what's up there? Excellent. So solve, graph, and check are the directions that I'm giving you right here. All right, so my example is I have -7 is less than y plus 5. So I want you all solving that, graphing it, and then check your solution. All right, keep going, but someone tell me, how did you solve this equation? Ava, how did you solve this? Excellent. So I get -12 is less than y. How many of you guys got that as your solution? All right, so our dot should be at -12. I'm going to count by 2's, so I'm going to put a -2 and a +2 on either side of that zeros. If you count it by 1's, that's fine. I just wanted to count by 2's. So where's my dot going? Where's my dot going? Blythe? What is my starting number? Excellent. I want to point out there will be people who go back to that -7 because that's what the original equation or inequality had by itself. Don't go back there. We are graphing our solution. All right, so Blythe, here's my -12. So 2, 4, 6, 8, 10, 12. Is it an open dot or a closed dot? Excellent. And which way am I shading? Am I shading bigger than or smaller than that? So what are all my y's in relation to my -12? They're bigger because the bigger part of the inequality is facing the y. So there's our solution. How many of you guys are cool with that? Questions on graphing these? Okay, so let's talk about story problems. I I want you guys setting them up exactly the same as we do equations. We're just going to throw an inequality symbol in there. So we're going to set up exactly the same as equations. But I want to talk to you about when we do our game plans, which is our parts equal to our whole. Let's talk a little bit more about what the whole means. When we have an inequality, our whole is still our total. However, it is going to be our maximum or minimum total. Minimum. There we go. Minimum total. All right. And our parts are the actual stuff we are doing. So it's the actual math. The whole is like your goal. And it's either a maximum or a minimum goal. Does that make sense to you guys? Kind of? All right, let's do a story problem. So you guys can kind of see what I mean by that maximum or minimum. Who needs to see what's up there? All right, so this is example 4 from page 142. If you ever are someone that goes back to that, it's from our book. Ashton, are you cool? Okay. Are you guys cool? Andrew, you got that? Awesome. All right, so how many of you guys have been up to like Boyne Mountain in the summer, or one of the ski, like even out west in a hill where there's ski lift? Okay. Have you guys ever gone up? Has anyone done the zip lining course at Boyne Mountain in the summer? Okay, that is so much fun. I totally dig that. That was a lot of fun. I did that one summer. If you haven't, go up there. It's really fun. All right, but people do mountain bike on the hills. So here's a picture of what we are talking about in this story problem. This dude's going up the ski hill so he can go mountain biking through the hill and around in the woods and stuff. Okay, so just so you have a picture of what I'm talking about. So here's our story problem. Okay, so what it says is, the maximum safe load of a chairlift like the one at the left is 680 pounds. The weight of a person on the lift is 124 pounds. The weight of the bike is 32 pounds. How much additional weight can a chairlift safely carry? All right, write all of that down, and we're going to talk about a game plan for this and how to solve this. Go on. Okay, so let's talk a little bit about this. I'm going to put up what I have. This is kind of a bullet point list of what they've told us. They told us the maximum load of the chairlift is 680 pounds. It says that the guy that's on there is 124 pounds. The bike is 32 pounds. We want to know how much additional weight. Okay, so parts equal to our whole. What information here is our whole? What information here is our whole? Kaylee? What information is that, though? So don't give me a number. What does that stand for? That's that maximum load. Maximum weight load. Maybe I'll write that down so we know it's weight. That's our maximum weight load. Okay. What is the actual that we are putting on the lift? What makes up the weight that's going on the lift? Ashton? So the bike weight plus the person's weight. What else? So now I'm not going to put a variable there. I'm going to go ahead and put what you just said down, our additional weight. But I do agree with you, that would be our variable. So this, the stuff on that lift, this is our actual weights that make up our maximum. Does that make sense to you guys? Yeah? Okay. So now someone write my inequality for me. Well, let's write it as an equation first, and then we'll turn it into an inequality. Someone write this out for me. Jacob?
So it would be 124 plus 32 plus x or y is equal to 680.
All right. Now what we need to do is we need to change this into an inequality. So change, and if you can go right to the inequality, that's fine with me. Okay? So I want to change to inequality. So what we're saying to ourselves is, what can our actual weights be in relation to the maximum? That's what we're looking for. So I'm going to go ahead and erase this. Well, what can our actual be in relation to a maximum? Victoria? Yeah, it's going to be less than or equal to. Because it's a maximum. What we can do can be less than that, or it can be exactly that. All right, all of you solve that. Yes?
So we have to write it as with an equal sign?
No, I just said to you guys, you do not have to write it as an equation. But if you start with the thought of an equation and then turn it into an equality, that's kind of what your brain's going to be doing. But you don't have to. I just want you to understand how to do it. Okay, all of you solve this. How many of you guys got x is less than or equal to 524? Awesome. What does that mean? Remember, you have to explain your answers, particularly with inequalities. What does that mean? What does that mean? Colin? Excellent. The most amount of, I'm going to write additional weight. Would be 524 pounds. But you have to say the most. You have to indicate that's an inequality. You can't say you can put 524, because that would be an equation. So you need to indicate in some way that that's the maximum. You guys cool with this? Do you guys remember doing some of this last year? It's kind of slowly coming back to you? Okay, you guys are good to go. Blythe. No, if they do not ask for you to graph, you do not have to graph. So only graph the ones they're telling you to graph. Good question.